Hey, welcome. In today's DIY video, I'm going to show you some tests that you can perform on a 4-wire smart ignition coil using basic tools like a multimeter and a traditional incandescent test light. But now, before we actually get to testing on the vehicle, let's just really quickly talk about some of the differences between a 4-wire smart ignition coil like we're dealing with on that car compared to a 2-wire traditional style ignition coil. One of the biggest differences is that we're not just going to be able to do a resistance test across our primary windings. On this 2-wire coil, that'd be a valid test that we can do. All we're really doing is measuring from one end of this wire through all the coils to this end of the wire. If it's intact, then we're probably okay. On a module style smart coil, we have this little control module inside that doesn't allow us to check the primary windings because we're not actually seeing the external connection through the pins that we're connecting to on here. So we're going to have to do some other testing. But a module coil does give us some really good test points to look at. So we'll start off with power. An ignition coil that is a 4-wire smart coil will always be fed with battery positive whenever the key is turned on. So we'll draw our line to battery positive. Now really that's going to be through some sort of a fuse of some kind, or maybe even a relay. There might be something else in the circuit. It's not going to connect back directly to battery positive, but you may have to look for a relay or a fuse within that circuit. Then we have battery negative. A 4-wire ignition coil is also going to be controlled or connected to battery negative whenever the key is turned on. So that's two great testing points that we can check for power and ground, actually making it to our ignition coil. Now the other 2 wires that we have are going from the ignition coil itself back to the ECM, or the engine control module. We have 1 wire, we'll call this our control wire, and then we have our 4th wire, we'll call this feedback. All right, so our control wire on this orange wire, that's communication happening from one computer to the other. The ECM tells the ignition coil to turn on, turn off, turn on, turn off, and that creates our spark coming out of our spark plug. Now a 4-wire coil also has this feedback wire, and that's the ignition coil communicating back to the ECM, telling the ECM that, hey, I turned on, I turned off, I turned on, I turned off. So it's this call and response that happens between these 2 control modules, these 2 computers, that is occurring here. Now this circuit we're not going to be able to do a lot of testing with. I'll show you a way that we can have an idea if it's working, but it's going to be hard to test the actual control circuit. The feedback circuit, the computer actually sends 5 volts off to the ignition coil, so we can definitely take a look at that one. So why don't we head over to the vehicle and we'll take a look what's going on there. All right, so again, we're just using some basic tools today, a socket and wrench set, a incandescent style test light, not an LED style. We want to actually put a little bit of load on our circuit, so an incandescent bulb style test light, and then just your typical multimeter that you can pick up at just about any store. So we're going to tackle this thing in a couple different ways. Let's start off by turning on the key. We're just going to go ahead and turn the ignition on. We're working on a 2006 Lexus IS 250 today, but we're going to get our ignition turned on because there's some checks that we can do that are key on, engine off, and then there's some other checks we'll do with the engine running. So we'll start off by unplugging our ignition coil. All right, so we want to check for power and ground first of all. Remember I said anytime the key is on, we should have power and ground to our coil. Okay, so we have our meter connected on volts DC, our 2 leads in, and we're going to start with our first lead, our black lead, onto battery negative. And then we're just going to start pinning out the connector, or very gently touching the pins of the connector, looking for voltage. So we'll start at this end, nothing, nothing. There's our 5 volts. So that's our feedback circuit. That's the computer, the engine control module, sending the voltage to our coil. So that looks good. And then this one should be battery positive. There we go, 12.05 volts. That's battery voltage on here. That's our power coming into the coil. Now we need to find our ground side. So what we're going to do is we're going to take our ground lead here and we're going to put it over onto the battery positive terminal now. making sure we're just on voltage and we're not putting the meter in series, we're going to check for ground here. So all we're doing is comparing a voltage differential between battery positive and whatever this is probing to. So if we were to go across the battery, we would read battery voltage. If we were to go to a ground point here in the engine, we should read battery voltage. So what we're looking for is ground, and I believe it should be this outside pin. There we go. So we have our ground side voltage here. So what we now know is we know that our two outside pins are power and ground. Now it's possible for them to read 12 volts like it's supposed to on a meter, but also then not be able to carry any current to actually make any work happen. So that's why we have our incandescent test light. This is going to put a small load on the circuit, and we'll be able to actually verify if this lights up, we can actually pass current along this circuit. We're not dealing with a potential resistance problem. So when we use our test light, we want to be very, very careful. Our goal here is not to wreck our connector. So we're just going to lightly touch the test light to both outside pins, not the middle ones, those are computer control circuits, just the two outside pins, and we're going to look for it to light up. There we go. Nice bright light out of our test light on the two outside pins, power and ground. We don't want to use this on those two control circuits, right? The control and the feedback circuit are computer controlled. We don't want to possibly let that magic smoke out of the computer by overloading the circuit with a test light. That's why we're only using the voltmeter on that circuit. Now what we're going to do, we're going to go ahead and plug this guy back in, and we're going to go ahead and back probe into the connector, because now it's time to check for control coming from the engine control module. So we're going to back probe into here, into the third wire in, the one that's right next to our ground wire that we tested. This one happens to be brown. We're going to put our meter over on the battery negative, and we're going to look for some sort of voltage to happen when our engine's running. Because what's happening now, actually let's put this back together so we can run the engine nicely. Plug in our mass airflow sensor. So what's actually happening now is we're going to watch the computer control the small module that's inside of the ignition coil. And we should see a very small amount of voltage on here. And then with this voltage, it should increase if we increase the speed of the engine. So what we're actually watching there is we're watching the command signal that's being sent into the ignition coil. The reason why it doesn't look like anything in particular is because the meter is too slow to pick up that command signal. The computer's commanding it very quickly, and the meter is averaging out the voltage level and displaying it back to us. This is where a lab scope would come in handy, so we can actually see that computer-to-computer speak that's happening, that digital square wave that's occurring in there. Our meter is able to pick up something. It's able to tell us that there's something occurring, but it's not a super definitive test. A lab scope would be necessary. But at this point, we're able to verify that the computer's trying to control the coil. We have power and ground to it, and we have our feedback circuit intact. It looks like if we're dealing with a bad ignition coil, that it would be just about time to change this out if this is all the tooling that you have access to. Now just remember, anytime you're changing out an ignition coil, you're going to want to figure out what the root cause was. Was it the coil that actually failed on its own, or did the spark plug take it out? A lot of times what happens is a spark plug might wear, and it's maybe over its maintenance interval or something, and it causes the coil to overwork, and it stresses it out, and the coil then fails. It's not the root cause. The coil's not the root cause at that point. You're going to want to put a spark plug in that vehicle as well. The other thing to do is when you remove your coil, pull out your bolt, pull out your coil, and you want to just make sure at the end here, along the spark plug boot itself, you want to make sure that it's not covered in oil. If it's covered in oil, you have a valve cover gasket or a seal between the spark plug tube and the valve cover is leaking, causing your ignition coil to fail. Again, the coil is the result of another cause, okay? So keep that in mind when you are getting to the point where you're replacing it. If it's covered in oil, you'll most likely need to do a valve cover gasket reseal as well. All right, so thank you for watching. We'll see you in the next one. Happy wrenching, everyone.